Hi everybody, and welcome to Go Formative Math Help. This is going to be about the AGS1 prep lessons that you will be facing some, if not all of this next year. And I'm calling this 51 and on is AGS1. We've done 1 through 50, and so we'll probably go to close to 80 lessons. And so each video will be about a week's worth of those lessons. Okay. So this is going to be about 52 through 59. It's not going to be a very long video, but you can rewatch it if you want. I'm not doing a lesson on 51 because 51 has its own video. You can go to 51. I recommend doing lesson 46 and 51, and that'll teach you some point slope. But we are going to start with some scatter plots, 52. So here's what you need to know about scatter plots. The main things, basic stuff. Okay. Scatter plots, basically if two dots, make a line, right? We already know that. But what if the dots are like all over the place? Then it's hard to make that line, okay? So if you're plotting on a graph and you're looking at a graph like this, it's hard to decide where a line should go. I could do my best to draw a line that covers like in between them, but that's not what this lesson necessarily is about. This could be considered a line of best fit, what I just drew, but that's really not what we're doing right now. You don't have to do the line of best fit. You just need to recognize the overall points on a graph, if it's a positive correlation, a negative correlation, or if there's no correlation. So let me give you an example of all three of those, okay? So this one is pretty random. So this is going to be considered no correlation, okay? Meaning that whatever this y-axis is called and whatever this x-axis is called, they have names, right? Like dollars per hour, right? This could be money and this could be hours. And maybe in this case, you're comparing two things that do not go together. If I were to think off the top of my head, two things that don't go together is how much money you make and how tall you are in height, right? So if somebody's really short, they can make a little bit of money, they can make a lot of money. If someone's really tall, they can make a little bit of money, they can make a lot of money. There's no such thing as like, well, tall people make more, or short people make more, or short people make less. So in that case, if we were comparing height and money, then there'd be no correlation. Okay. Something like your dollars per hour example, right? So the more money, the more hours you work, the more money you made if you were getting paid hourly. So we could set it up as this is the money you make, and these are the hours you work, or other way around. These are the hours you work, this is the money you make, right? So if I work, 1, 2, 3, 4, if I work, 5 hours, I'll make more money than if I were to work 1 hour. Okay. And some people make a certain amount of money to do 2 hours of work. Other people work 2 hours, they make this amount. Other people work 2 hours and make this amount. Some people work 3 and make this amount. Some people make, 4, 5, 6, right? So if you look at this, look at the trend of this, right? Where's it going? It's going this direction. And so what we do for scatter plots, we would say this is a positive correlation. positive correlation because it is going up and to the right. Okay. And then obviously you know what's coming next is a negative correlation, and negative correlation would be something that looks like this. And so then if I were to draw that line, which again, we're not drawing the line, but you do need to see the trend. This is a negative correlation. So review, there's only 3 of them. No correlation, all over the place. Positive correlation, it's still all over the place, but it is trending upward to the right. And then this is a negative correlation down to the right. That's scatter plots. Next lesson is 53. And this is about this equation, y2 minus y1 over x2 minus x1. This is basically saying 2 coordinates on a graph can be plugged into an equation and you can find the slope of that line. So let me give you an example. So if let's just use easy peasy, lemon squeezy, okay? If I were to do 1, 1, and let's say it goes up 2 over 1, so 1, 3, I can see that it goes, up 2 and over 1. Therefore, the slope is 2 over 1. The slope is 2. But the point of this equation is if I can't count up and over, or it's too much for me to count up and over, or sometimes I don't know, maybe I want to use the equation instead, you can simply take the 2 coordinates of these 2 dots, these points on the line, and you can plug them into this equation. So for example, let's call x1 and y1 the first coordinate, and that's 1, 1. That's this one. Okay. And then let's call x2 and y2 the next coordinate, which is 2, 3. So if you know which one's which, then you simply just plug them into the equation. The equation says y2 take away y1. So y2 is 3 and y1 is 1. So on top is going to be 3 take away 1. On the bottom is going to be x2 take away x1. Well, then x2 is 2 minus 1. 2 minus 1. And if you do the math on that, what you end up with is 2 over 1, which means the slope is 2. Now, we already knew the slope was 2 because we counted at the beginning up 2 over 1. So it's not going to give you a different slope. What it's going to do, it's going to give you the slope without counting on a graph. Okay. Why is this useful? Well, if your teacher ever gives you, here's 2 coordinates, go, you can just plug them right into this and you got it. You can get to the slope faster. That's one beneficial thing. If you do not know how to do this, then the teacher gives you those 2 coordinates. You need to make the graph, plot the points correctly on the graph, and then draw the line, and then count up and over and see for yourself what the slope is. So it is going to save you time if you learn this formula. Okay. What's the tricky part about this? The tricky part about this is if they give you perhaps like something like this. They give you a negative kind of, let's say for whatever reason they give you like -2, -2, and then the next one is 0, 2. So we have 0, 2 and -2, -2. but you still need the formula y2 minus y1 over x2 minus x1. You can pick wherever one you want to pick, okay, to start. You can start with this one and call that one your x1, y1, or you can pick the other one. It doesn't matter. You need to pick. So I'm choosing this. So the y2 minus y1 is going to be negative 2 minus 2. Okay, negative 2 minus 2. And if I were to do it the other way, where I choose like this one first, then it'd be 2 minus a negative 2, and that's always gets 8th graders, the negative situation. Okay, and then the next thing would be to do x2 over x2 over x1. x2 is negative 2, and then minus 0. So what do you have here? You have negative 4 over negative 2, and that cancels to 4 over 2, which cancels to just 2, so the slope must be 2 again. Let's count for ourselves. Up 1, up 2, up 3, up 4, over 1, over 2. So we're looking at a slope of 4 over 2, which is still 2, so the slope is 2, even if we use some negatives or whatnot, okay? And like I said, if you do it backwards, right? Let's say I chose backwards would be me choosing the other coordinate. This is going to be x2, y2, and this is going to be x1, y1. You should still, no matter which way you choose, you should still get the same slope, assuming your math is correct. So it's going to be 2 take away a negative 2 over 0 minus a negative 2. But those are going to all cancel out, and you end up with 4 over 2, which is just 2. Okay, so that's that. That is 53. Let's go on to 54. 54 is order of operations. Just remember for 54, I think that lesson's pretty self-explanatory. Plus, it's more of a review. There's a review, review, and then it starts out with some review. I'll just show you this one. 9 plus 6 divided by 8 take away 2. So if you remember parentheses, exponents, multiply, divide, add, subtract. The key here is the parentheses is first. So we're going to do that first. So 8 minus 2 is 6. And then we need to rewrite it. And that's the step that kids don't want to do. They don't want to rewrite it. So now the question is, what comes next? The chicken or the egg? Okay, so 9 plus 6 divided by 6. You have to know that division is the priority. So 6 divided by 6 is 1, and 9 plus 1 is 10. So when you go do this one, just remember the order. Parentheses goes first. Look in there. Rewrite, 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 rewrite. This is the part nobody wants to do. But if you do it, you'll be just fine. Okay. Let's go to Pythagorean Theorem review. I'm not going to do too many of these, but I'll do one forwards and one backwards as a review if you need. Let's go with this one. So we have a triangle. And for the sake of this problem, we'll call it a right triangle. Okay. I have students that would be like, oh, that's not right. Okay, so it looks good. Let's call this 8 and this 6. We don't know what this is. Remember, we're using a squared plus b squared equals c squared. That's the formula. The longest side has a name called the hypotenuse, and that is what C is always. A and B can be interchangeable. These are A or B, okay? So let's go 6 squared plus 8 squared equals C squared. And now I'm just solving. 6 times 6 is 36. 8 times 8 is 64. And adding those together, I'm getting 100 equals C squared. You should know this, but there's only one way to get rid of a square, and that is by doing the inverse operation of a square, which is square rooting. But whatever I do to one side, I have to do to the other. So C is going to be 10. I butchered that, 10. And actually, C is going to be plus or minus 10. It's got two answers. But when you're doing triangles and stuff, they don't use the negative. But I think it's important to mention that when you're going on these higher level maths, that if you square root anything, it's going to have a positive negative of itself. So I think it's important to realize, because negative 10 times negative 10 is still 100, and 10 times 10 is 100. So square root of 100 is going to be both negative 10 and 10. But for this, we can just put 10 and call it good. Okay. It's a beautiful box. Let's just try it again. Let's see what happens if I do this. Perfect. It's beautiful. I love it. Okay. That's Pythagorean theorem. I think if you were working backwards, you know, if someone wanted you to do the same problem, but let's see if I draw a triangle. Will it make a triangle for me? Let's go. Okay. So if you know how it was 6, 8, and 10 just now, let's make it not 10 and say it's 9. A common question would be, okay, if I do this, will I get 9? And the answer is no, I'm going to get 10. So then this is not Pythagorean theorem. So what does that mean? It means that this angle right here would not be a 90-degree angle. It wouldn't be. This would have to be 10 for that to be 90 degrees. And so that's kind of the whole point to this, is you recognizing where the 90-degree angle is. So if it's not 9 and it is 10, then we know exactly this is 90 degrees. So that's something to keep in mind. That's really the whole point. Let's say for the sake of conversation, we were going to do like, you know, the 9 was going to be there, right? And then this was like unknown. Well, we could find it if we say, okay, this is 90 degrees. It's not going to be nice and neat, but we can still find it by working backwards. So 6 squared plus b squared equals 9 squared. We take that hypotenuse alongside and we put it at the end. We can call this A or B, doesn't matter. And we don't know what it is, right? So this is 36 plus b squared equals 81. Why 81? 9 times 9. A common mistake amongst 7th and 8th graders is they think 9 squared means 9 times 2. This is not 9 times 2. This is 9 times 9. Okay. Now that you're sitting here, you have to subtract 36 from both sides. So what's 81 take away 36? All right, we do this. So 45. So you have b squared equals 45. And you know the square root rule, we got to do that. But the thing is, if I throw the square root of 45 in the calculator, the good old calculator, 45 square root 6.708, and the 8 would round to 6.71. So the answer is 6.71. So b equals 6.71. Another way to think about doing this is just reducing the radical by breaking this down into two smaller radicals that multiply. So you see how 9 times 5 is 45, so the square root of 45 equals the square root of 9 times the square root of 5. But why do I like this? Because it's a perfect square. So the square root of 9 is actually what? 3. And 3 radical 5 could be our simplified radical. So I could say b equals 3 radical 5 instead of saying b equals 6.71. Now, if I go back to that calculator, right, radical 5, you're going to make me watch a show. Okay, cool. Thank you. If I take radical 5, boom, right, and then times it by 3, does that look familiar? 6.71. It's the same. See, well, let's see it again. Watch. 45. Square root of that is 6.708. And if I just take radical 5 and times it by 3, I get the same answer. So my point is that they do equal the same thing. These guys touching, that means 3 times radical 5 is the same as 6.71 rounded. So we can reduce the radical, or we can just put the decimal, and you'll have classes in the future that say, please reduce the radical. Or you're going to have classes in the future that say, just give me the decimal or whatever, they don't care. You have 2 Pythagorean Theorem lessons there. I don't need to go over much more than that. So let's go on to 57, 58, and 59. Those are all on transformations. Transformation twister is basically you plotting coordinates and then you moving that shape. Okay. Paper, boom. All right, so let's say that you have to plot this first one. Two comma 1 is A, 2 comma 5 is B, 1 comma 5 is C, and negative 5, negative 5. Oh, no. Oh, it's a triangle. Okay, cool. All right, so I'm connecting my dots. I'm like, negative 5, negative 5, doesn't make sense. It wants me to move the shape negative 5 spaces to the left, and then negative 5 spaces down. Okay, and then negative 5 spaces down. This is basically what's want me to do, which we can do that with each point. We can just move each piece to the left 5 and down 5, each coordinate. So 1, 2, 3, 4, 5, 1, 2, 3. And you see here. And pretty much once you have the first one right, you don't have to count the rest. You know that B is right next to it, and you also know that these are only 4 apart. So they still need to be 4 apart. And this is your new A, your new C, your new B. And if you don't trust yourself, you can always count it again. 1, 2, 3, 5, 1, 2, 3, 4, 5. Then you know for sure. Okay, so that is literally how you do the first one of those. And you have a bunch of those. Okay. The problems after that, they will tell you to maybe reflect or to talk about other transformations. Let's just do a review. You just saw me translate it. How would I reflect this piece over the x-axis? Okay. How would I reflect it over? It would be a mirrored image. There's your A prime, and then 4 away would be your B prime. 1 next to it is your C prime. And I could, there's your reflected image, and I could also reflect it over the y-axis as well. Same thing, B prime, C prime. So we can do that. You can rotate it. You could, let's change color. You can rotate clockwise 90 degrees and put B down here 4 apart from A, and then C is in front of it. Something you could do. So rotation, that's a term. There's dilation, where you enlarge. There's reflection. Which is like a mirrored image. Enlarge. It's like a mirrored image. And then translation, which is a slide. Translation, which is a slide. Turn, enlarge, slide. And this is like a mirrored image. Okay. Just flipping if you need a different word. Flip. That is it for today. The thing to remember would be that your dilation is usually a multiplication of the factor. So times 2 or times 3, or you take all the coordinates. If the coordinates was 1, 2, and you need times by 2, then the new coordinates 2, 4. So if you're asked to dilate by 2, then you would times everything by 2. If you're asked to dilate by a half, you would times everything by a half. So keep that in mind, that your dilation is a multiplication of the whatever factor you're being asked to multiply by. I'll click on 59 so you can look at it. 59 is like vocab. I think you'll be good with that. You're matching and reading. 15, there's only like 6 problems on this one, and it's pretty self-explanatory. You'll be good at this. Determine if the two figures are similar by using transformations. Explain the reasoning. Do you remember what we talked about, similar and congruent? And you guys, the lesson I taught, you guys really understood similar triangles, similar shapes. If you really need to look at the sides of the shape and count the sides and see, okay, this triangle is a what by what. So look at the small one. It's 3 by 4. See that? So 3 by 4, 3 by 4. And then look at the big one. It's 1, 2, 3, 4, 5, 6 by 1, 2, 4, 5, 6, 7, 8. A 6 by 8. So we can do 1, 2, 3, 4, 5, 6, and 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Looks weird, but there it is. So you're 6, 1, 2, 3, 4, 5, 6, 7. Oh, that's why it's weird. Because you're 7, bro. I'll just do it over here. 3, 5, 6. And then by 8. And so something to think about is, okay, 6 by 8. Okay, see how this is exactly times 2? Because 3 times 2 is 6, and 4 times 2 is 8. So these are similar. So the answer would be yes, they're similar. And so that's something that you'd be able to talk about, is determine if the two figures are similar by using transformation. So you might be like, okay, how do we see if they're it's not really asking are they similar triangles. They're saying perhaps are they similar, and can you prove it through transformation? So I'm thinking maybe a rotation and then a dilation, perhaps could do that. So something to think about. You can talk about that in your response and looking at it. But yeah, we can turn the little one, or we can turn the big one and reduce it. So that'd be something we could do. Then we have triangles that there's no graph. You have to kind of think about this. Okay, this has this, it gives you the coordinates, and then it tells you now the new vertices are these. Okay, what type of reflection is that and why? So you might have to grab some graph paper or some paper and you draw it out and you figure it out. So that's about as hard as the transformations get, as you might have to do some of these. So that's it for this video, and I'll tell you what's coming up next is a whole bunch of graphing. We're literally going to do all the functions, absolute value functions, square root functions, cubic functions. These are all coming. Next week's video will be all about that. And I'm only releasing 51 through 59 this week. That's your homework. We'll do that. And then next week we'll do some homework here. And then the week after. And then we're done. I mean, school is almost out. Thank you.